Picture a galaxy frozen in time, an ancient cosmic relic that has drifted through the universe for billions of years, virtually untouched by the chaotic dance of cosmic evolution. This is NGC 1277, a galaxy so perfectly preserved it's like a living fossil from the early universe, a window into a time when galaxies were just beginning to form their identities. While most galaxies have been shaped and reshaped by collisions, star formation, and the relentless pull of dark matter, NGC 1277 has remained remarkably unchanged for over 10 billion years, making it one of the most pristine time capsules astronomers have ever discovered. What makes this galaxy even more extraordinary isn't just its age or its untouched state, but the 30 mysterious objects lurking within its boundaries that defy everything we thought we knew about how galaxies work. These aren't just unusual stars or strange nebulae. They're cosmic anomalies that challenge the very foundations of astronomy, pushing scientists to reconsider what's possible in our universe. Imagine looking at a photograph from the distant past and noticing details that shouldn't be there. Elements that break the rules of physics as we understand them. That's exactly what researchers faced when they peered into the heart of NGC 1277 and found these enigmatic structures. Each one tells a story that doesn't quite fit with our models of galactic evolution, hinting at processes and phenomena we haven't yet begun to comprehend. Some of these objects appear to be supermassive black holes where none should exist. Others seem to be clusters of stars orbiting in patterns that defy gravitational logic, and a few exhibit energies and light signatures that have no clear explanation within current astrophysical theory. They are cosmic puzzles waiting to be solved, each one holding clues not just about this peculiar galaxy, but about the fundamental laws that govern our entire universe. This journey into NGC 1277 isn't just about cataloging strange celestial objects, it's about venturing into the unknown and confronting mysteries that could reshape our understanding of reality itself. As we explore these 30 anomalies, we'll uncover why this ancient galaxy holds such fascination for astronomers and how these discoveries might revolutionize everything from dark matter research to the life cycles of galaxies. You're about to witness one of the most extraordinary astronomical detective stories of our time, where every clue leads to deeper questions, and every answer reveals just how much we still have to learn about the cosmos. So join me as we dive into the heart of this cosmic relic and uncover the secrets of 30 objects that shouldn't exist, but somehow do, challenging us to rethink everything we know about the universe. Right at the very heart of this ancient galaxy lies its first and perhaps most profound mystery, a cosmic heavyweight that defies all expectations. We're talking about the supermassive black hole at the core of NGC 1277, but to call it merely supermassive feels like a dramatic understatement. This isn't just a large black hole. It's a behemoth of almost incomprehensible scale, an entity so disproportionately massive that it single-handedly upends our established theories of how galaxies and their central black holes grow together. While astronomers have studied supermassive black holes for decades and found they typically make up a tiny fraction of a galaxy's total mass, usually around 0.1%, the one in NGC 1277 is an absolute outlier. It doesn't follow the rules. This colossal void in space accounts for a staggering 14% of the entire galaxy's mass. To put that into perspective, imagine if the brain of a human being made up 14% of their total body weight. For an average person, that would mean a brain weighing over 20 pounds, a biological impossibility under everything we know. That's the level of anomaly we're dealing with here. A central black hole that simply should not exist according to our current models of physics. The conventional wisdom in astrophysics has long suggested a kind of symbiotic relationship between a galaxy and its central black hole. They're thought to evolve in lockstep, growing together over billions of years through mergers and the accretion of material. The gravitational influence of the black hole is believed to regulate star formation and even inject energy back into the galaxy, creating a feedback loop that keeps everything in a delicate balance. But the discovery of this 14% monster shatters that elegant picture. It suggests a formation history that is radically different from anything we've seen before. One compelling theory is that NGC 1277's black hole grew to its immense size during a period of extremely rapid accretion in the very early universe, a chaotic time when vast reservoirs of gas collapsed directly into it without the regulating mechanisms we see in later epochs. It's as if this black hole had a growth spurt in its cosmic youth and then, for reasons we don't yet understand, that growth just stopped, leaving the rest of the galaxy frozen in its ancient state, while the black hole became a relic of a more violent and extreme time. This discovery forces us to ask fundamental questions about the very nature of these gravitational giants. Could there be an entirely different, unknown pathway for black hole formation that bypasses the standard models we've relied on? Does this mean that in the early universe, the rules were different, allowing for the creation of such disproportionate objects? The existence of this black hole doesn't just challenge a single theory. It forces a broader rethink of how matter behaves under extreme gravitational forces and how the seeds of the first black holes were actually sown. It stands as a monumental puzzle, a cosmic paradox that reminds us that for every rule we think we've uncovered about the universe, there is often an exception waiting in the shadows, ready to rewrite the textbooks. Yet if the supermassive black hole presents one colossal puzzle, the second mysterious object in this ancient galaxy presents a problem that is arguably even more profound, because it involves something that isn't there at all. We are talking about a stunning void, a profound absence of the very thing that astronomers believe holds the universe together: dark matter. In every other galaxy we have ever studied, from our own Milky Way to the most distant spirals, dark matter is the invisible king, the dominant force that makes up the vast majority of the mass. It is the unseen scaffolding, the gravitational glue that binds galaxies together and dictates their very structure and rotation. For a galaxy the size and mass of NGC 1277, our models confidently predict that dark matter should account for a huge portion of its total mass, perhaps as much as 80 or 90%. But the observations tell a completely different and utterly baffling story. When scientists measured the motions of stars within this galaxy, tracing their orbits to calculate the gravitational forces at play, they found something that should be impossible. The stars are moving in ways that indicate there is simply not enough mass present to hold the galaxy together. And after accounting for all the visible matter, the stars, the gas, the dust, and even that enormous central black hole, there is a terrifyingly vast amount of mass that is just missing. The conclusion is inescapable. NGC 1277 appears to be severely deficient in dark matter, a finding that strikes at the very heart of modern cosmology. This discovery sends shockwaves through our understanding of how galaxies form and endure. Think of dark matter as the cosmic framework upon which ordinary matter accumulates, like ivy growing on an invisible trellis. In the early universe, vast halos of dark matter are thought to have collapsed first, their immense gravitational pull acting as a nursery, gathering the gas that would eventually cool and form the stars we see. Without this dark matter anchor, a galaxy as massive and structured as NGC 1277 simply shouldn't exist. It should have flown apart eons ago, its stars scattered into the void. The fact that it hasn't, that it has remained intact and pristine for over 10 billion years, forces us to confront two equally unsettling possibilities. Either our methods for detecting dark matter are fundamentally flawed, or our core understanding of gravity itself is incomplete. This isn't just a missing puzzle piece, it's a suggestion that the entire puzzle might be assembled incorrectly. How could a galaxy form without this essential ingredient? One compelling, though speculative, theory suggests that NGC 1277 might be a rare relic of a direct collapse galaxy, forming in the incredibly dense and turbulent environment of the early universe. In this scenario, vast clouds of pure baryonic matter, the ordinary atoms that make up stars and planets, could have collapsed under their own gravity so rapidly and violently that they forged a galaxy without the need for a dark matter skeleton. Alternatively, it's possible this galaxy did once have a dark matter halo, but it was somehow stripped away in a catastrophic event, a gravitational theft on a cosmic scale. Perhaps it ventured too close to the heart of its galaxy cluster, where the immense tidal forces could have ripped this invisible component away, leaving behind only the glittering shell of stars. Each explanation is extraordinary and challenges foundational principles of physics, presenting us with a cosmic ghost, a galaxy that by all rights shouldn't be, yet defiantly is. Moving outward from the galaxy's mysterious core, we encounter a third object that, unlike the missing dark matter, is very much present and visible, yet no less revolutionary. This is the ancient globular cluster system of NGC 1277. Imagine finding a collection of cosmic diamonds, each one a dense sphere of hundreds of thousands of stars, all forged in a single, furious burst of creation over 10 billion years ago, and then left virtually untouched, their brilliance undimmed by time. That is precisely what surrounds this galaxy, a population of these ancient star clusters that are so old and pristine, they act as a living record of the universe's infancy. In most galaxies, globular clusters tell a complex story, with multiple generations of stars indicating a long and turbulent history of mergers and acquisitions. But the clusters orbiting NGC 1277 are different. They are almost entirely uniform in age and composition, suggesting they all formed together in one incredibly rapid and efficient burst of star formation very early on, and then nothing. The galaxy essentially closed its star-making factories, preserving these clusters in a state of suspended animation. This singular event offers astronomers a uniquely clear window into the conditions of the early universe. The chemical composition of these stars is like a cosmic fingerprint, revealing a primordial environment almost entirely devoid of the heavy elements that are forged in the hearts of stars and spread by supernova explosions. This purity indicates they formed from gas that had not yet been polluted by previous generations of stars, making them perfect laboratories to study the very first steps of cosmic chemical evolution. By studying the light from these ancient suns, we can virtually peer back in time to witness the universe's first major period of star birth, an epoch that set the stage for everything that followed. The fact that this entire system formed in one go suggests that NGC 1277 experienced an initial, incredibly intense wave of star formation that consumed its entire reservoir of gas in a relatively short cosmic timespan, perhaps due to the overwhelming gravitational influence of its monstrous central black hole. The sheer number of these clusters is also a significant clue. Larger galaxies tend to possess more globular clusters, a relationship that has held up across the cosmos. Yet again, NGC 1277 defies this trend. For a galaxy of its size, it possesses a surprisingly small number of these ancient clusters. This scarcity further supports the idea of its isolated, relic nature. It never underwent the major galactic mergers that would have stripped it of its own clusters or donated new, younger ones from other galaxies. Its cluster system is therefore original equipment, a factory-set feature from the dawn of time that has never been upgraded or altered. This pristine system doesn't just tell us about how this one peculiar galaxy formed. It provides a critical baseline for understanding the violent and messy processes that shaped every other galaxy we see. In its untouched simplicity, we find a stark contrast that helps us decipher the complex history of our own Milky Way and the countless other galaxies that continue to evolve and change long after NGC 1277 pressed pause on its own development. But perhaps the most telling characteristic of this fossil galaxy is written in the very light of its stars, a chemical signature that reveals a universe abruptly paused. When we analyze the starlight from NGC 1277, we find a population of stars that are strikingly deficient in what astronomers call metals, any element heavier than hydrogen and helium. This metal-poor stellar population is a direct and profound piece of evidence that this galaxy effectively shut down its star-forming operations an astonishing 10 billion years ago. In the cosmic foundry, metals are forged in the nuclear furnaces of massive stars, and then scattered across space in violent supernova explosions, seeding clouds of gas that will one day collapse into new, more metal-rich generations of stars. Our own Sun, for instance, is considered metal-rich, a product of countless generations of stellar recycling that enriched its birth cloud with elements like carbon, oxygen, and iron. The stars in NGC 1277, by contrast, are like celestial time capsules, preserving the pristine composition of the universe's first stellar generation. They are almost pure hydrogen and helium, with metal content hundreds of times lower than what we see in stars from younger galaxies like our own. This extreme metal poverty is the key to understanding the galaxy's frozen state. It indicates a star formation history that was both incredibly intense and incredibly brief. Picture a massive, primordial reservoir of pure gas collapsing under its own gravity, igniting a ferocious firestorm of star birth. For a short, brilliant period, this galaxy would have been one of the most luminous objects in the entire early universe. But then, something catastrophic happened. The very engine of its creation, the immense supermassive black hole at its heart, may have also been its undoing. The theory is that as the black hole gorged on matter, it unleashed unimaginable torrents of energy in the form of powerful jets and radiation, blasting away the remaining star-forming gas and effectively starving the galaxy. With no fresh gas to collapse into new stars, the process simply stopped. The galaxy was left with only its first, metal-poor generation of stars to slowly burn out over the eons, a glittering fossil record of that single, explosive chapter of creation. This makes NGC 1277 a unique laboratory for studying the earliest phases of star formation. In most galaxies, including our Milky Way, the chemical record has been overwritten and muddled by continuous cycles of birth, death, and rebirth. It's like trying to read an ancient parchment that has been written on, erased, and written on again many times. But here, the record is clean. The story is simple and singular. By studying the exact metal content and distribution in these ancient stars, astronomers can answer fundamental questions about how the very first stars formed. Did they form in isolation or in massive clusters? What was the distribution of their sizes? The answers are locked in the light of these primordial suns, offering a clarity that is simply unavailable anywhere else in the nearby universe. This galaxy doesn't just show us what the early universe looked like. It provides the raw, unedited data we need to finally understand how it all began. And while the chemistry of its stars tells a story of a universe paused, the very shape of this ancient galaxy reveals an equally profound level of preservation. Most large galaxies we observe today, including our own Milky Way, are not the pure, simple spirals or smooth ellipticals they once were. They are cosmic hybrids, their structures warped, thickened, and fundamentally altered by a long history of violent collisions and mergers with other galaxies. These interactions are a fundamental part of cosmic evolution, stirring up stellar orbits, triggering new waves of star formation, and ultimately erasing the pristine features of a galaxy's youth. But NGC 1277 is a stunning exception to this rule. It possesses what astronomers call a relic disk, a vast, thin, and incredibly orderly structure of stars that has remained completely undisturbed for over 10 billion years. This is not a galaxy that has been gently aging. It is a galaxy that has been hermetically sealed, its original form frozen in a state of perfect preservation. Imagine a gigantic, spinning celestial record from the dawn of time, with stars moving in neat, circular orbits around the center, all aligned in a remarkably flat plane. There is no signs of the bulge of randomly orbiting stars that typically puffs up the center of spiral galaxies over time. There is no evidence of a surrounding halo of stars tossed out of place by ancient mergers. This galaxy's disk is so pristine and thin that it more closely resembles a newly formed galaxy in the early universe than a mature one in the modern era. It's as if we've discovered a vintage car, not in a museum, but still on the road, having never been in an accident, never been modified, and with all its original parts functioning perfectly. This level of structural purity is almost unheard of in the present-day universe, making this relic disk one of the most valuable artifacts an astronomer could hope to find. The existence of this perfect disk tells us two incredible things. First, it confirms that NGC 1277 has lived an incredibly isolated and quiet life. It has managed to avoid any significant gravitational interactions with other galaxies for its entire existence. In the crowded environment of a galaxy cluster, this is an extraordinary feat of cosmic avoidance. It's like a single house in a dense city, remaining completely untouched while every building around it has been renovated, expanded, or demolished and rebuilt. This isolation is what has protected its delicate structure from the gravitational harassment that would have otherwise scrambled its stars into a more rounded, bloated shape. Secondly, and perhaps more importantly, this relic disk challenges our ideas about what is required for a galaxy to maintain its structure over such immense timescales. Recall that this galaxy appears to be missing its dark matter halo, the very component we believe provides the gravitational scaffolding that stabilizes a galaxy and allows a thin disk to form in the first place. So how has this delicate disk remained so perfectly intact for so long without that crucial anchor? Its continued existence is a gravitational paradox. It suggests that either our measurements of the missing dark matter are somehow incorrect, or that our understanding of galactic dynamics and stability is missing a crucial piece of the puzzle. This perfectly preserved disk isn't just a beautiful fossil. It's a fundamental test of our physics, a structure that by all rights should not have survived, yet shines on as a beacon from the universe's earliest chapters. As we move from the galaxy's pristine structure to the invisible energies that surround it, we encounter a mystery that isn't seen but heard, a powerful signal emanating from the void. Designated with the rather unassuming name J0319 plus 4130, this object is one of the most enigmatic radio sources ever detected in association with a galaxy. Unlike the visible starlight or the gravitational pull we've discussed so far, this phenomenon reveals itself through colossal bursts of radio waves, a form of low-frequency energy that paints a completely different picture of the cosmos. What makes this source so baffling is its raw power and its stubborn refusal to be neatly categorized. It pumps out a tremendous amount of energy, yet it doesn't match the signature of any known celestial object. It's not the rhythmic pulse of a spinning neutron star, or the chaotic roar from the accretion disk of an active supermassive black hole. It's something else entirely, an anonymous broadcaster sending out a powerful signal whose origin and purpose we simply cannot decipher. The discovery of such a potent and unidentified radio source in this specific galaxy adds a profound layer of intrigue. Remember, NGC 1277 is a relic, a place where time has effectively stood still. It is not a galaxy known for energetic outbursts or violent events in its recent history. Finding a source like J0319 plus 4130 here is akin to discovering a powerful, hidden transmitter inside an ancient, sealed tomb. It forces us to ask what natural process, frozen in time for billions of years, could still be generating such intense energy. The radio waves we detect are the echo of some massive release of power, but the engine behind it remains completely hidden from our view. This isn't just a puzzle. It's a direct challenge to our ability to interpret the universe's energetic phenomena, suggesting there are entire classes of high-energy events or objects that we have not yet even begun to imagine. Scientists have explored several compelling theories to explain this radio enigma. One possibility is that we are witnessing the aftermath of a truly cataclysmic event, such as the merger of two incredibly dense objects like neutron stars or black holes that occurred in the galaxy's distant past. Such a collision would unleash a titanic blast of energy, some of which would be emitted as radio waves that could persist for a long time as a fading afterglow. Another, even more exotic idea is that this signal could be the signature of a type of black hole that is itself a relic from the early universe, a so-called intermediate mass black hole. These are black holes that are larger than those formed from collapsing stars, but smaller than the supermassive giants at galactic centers. They are theoretical missing links in black hole evolution, and one residing in NGC 1277 could be accreting matter in a unique, unpredictable way, producing this unusual radio signature. Perhaps the most fascinating and mind-bending possibility is that this source isn't a single object at all, but rather a previously unknown type of structure or interaction. Could it be a vast natural particle accelerator, far more powerful than anything we could build on Earth, flinging matter and energy around with unimaginable force? Or does its presence hint at a deeper connection between dark matter and energetic emissions? Some speculative theories suggest that the decay or annihilation of certain types of dark matter particles could produce bursts of radio energy. If that were true, this mysterious signal could be our first direct glimpse into the properties of the invisible material that makes up most of the universe's mass. Each theory pushes the boundaries of known physics, turning this one radio source into a beacon pointing toward entirely new realms of cosmic discovery. Its very existence in such an ancient galaxy suggests that the early universe might have been host to physical processes and object types that are now extinct, making NGC 1277 not just a frozen relic, but a cosmic archive preserving evidence of a forgotten chapter in the history of the cosmos. Moving beyond the enigmatic radio emissions, we stumble upon a phenomenon that warps the very fabric of space and time around this ancient galaxy, creating a cosmic illusion that reveals hidden truths. Gravitational lensing is one of astronomy's most powerful tools, a natural telescope predicted by Einstein where the immense gravity of a massive object, like a galaxy cluster, bends and magnifies the light from more distant objects behind it. This effect allows us to see galaxies that would otherwise be far too faint and distant to detect. However, when scientists turned their gaze toward NGC 1277, they observed a lensing effect that defies all expectations. The way this galaxy bends the light of background objects is subtly but significantly wrong. Based on the amount of visible mass we can see, all its stars, gas, and that colossal central black hole, the lensing should be much weaker. The observed effect is far stronger, implying there is a tremendous amount of additional mass present that is completely invisible to our telescopes. This is the gravitational lens anomaly, a profound discrepancy that points to forces and matter we cannot directly see. This creates a fascinating and deeply puzzling contradiction with the other great mystery of this galaxy. Recall that the motion of stars within NGC 1277 suggests a shocking lack of dark matter, as there doesn't seem to be enough gravitational glue to hold the galaxy together. Yet here, the lensing effect tells the opposite story, screaming that there is, in fact, a huge amount of mass warping space around it. So which is it? Is the dark matter missing, or is it hiding in plain sight? This paradox forces astronomers to consider some truly groundbreaking possibilities. One explanation could be that the dark matter in this relic galaxy is not missing. but is instead distributed in a way we've never encountered before. Perhaps it is locked away in an extremely dense, compact halo right at the galaxy's center, so concentrated that it doesn't influence the orbits of the outer stars in the way we're used to measuring, but its immense density powerfully warps the path of light from background sources. This would be a completely new configuration for dark matter, challenging our models of how this elusive substance behaves and clusters. Another, even more radical theory ventures beyond the realm of known physics altogether. What if our understanding of gravity itself is incomplete on these vast scales? The current laws of gravity, as described by Einstein's theory of general relativity, have passed every test we've thrown at them for over a century. But this anomaly could be a hint that in unique environments like this pristine fossil galaxy, gravity operates by slightly different rules. Alternative theories of gravity, such as modified Newtonian dynamics or MND, propose that the effects we attribute to dark matter are actually due to a slight modification of gravity's strength over immense distances. While MND has had mixed success explaining observations in other contexts, the unique and pristine conditions of NGC 1277 make it an ideal laboratory to test such ideas. The strong lensing effect here could be a crucial piece of evidence that our fundamental model of how gravity works requires an update when applied to the largest structures in the universe. This single anomaly doesn't just present two conflicting stories. It opens a door to a much deeper mystery about the nature of mass and gravity. It suggests that our standard toolkit for weighing the universe might be flawed, or that we are witnessing the signature of something entirely new. The lensing effect acts like an X-ray, revealing the skeleton of the galaxy's gravitational field. And that skeleton appears to be far more massive and complex than the visible body would suggest. Unraveling this paradox is not just about solving the riddle of one peculiar galaxy. It's about calibrating the very scales we use to measure the cosmos. The outcome could redefine the most abundant substance in the universe, dark matter. Or it could force a rewrite of the cosmic laws that have guided our understanding for generations, proving that even our most fundamental constants might be subject to the quirks of an ancient and evolving universe. Deep within the heart of this ancient galaxy lies a central region so bizarrely packed with stars that it defies our understanding of cosmic architecture. Imagine a space that should, by all rights, be dominated by the terrifying emptiness of its supermassive black hole, yet instead it's crammed with stellar bodies. We're talking about the extraordinarily dense core of NGC 1277, a place where stars are packed together with an intensity that far exceeds anything our models predicted for a galaxy of this type and age. In most galaxies, stars in the central bulge maintain a certain respectful distance from one another, their orbits dictated by a balance of gravity and motion. But here, the stellar density is off the charts, creating a gravitational environment of such extremes that it could be hosting stellar phenomena we have only theorized about. This incredible compactness presents a fascinating puzzle. How did so many stars end up in such a tight configuration? And why have they remained there for billions of years without being flung out into the void or devoured by the central black hole? One compelling theory points back to the galaxy's unique formation history. During that initial, ferocious burst of star formation, an immense amount of gas may have been funneled directly into the galactic center, perhaps by the gravitational influence of the growing black hole itself. This gas would have collapsed into a phenomenal number of stars in a very small volume, essentially creating a stellar traffic jam from which there was no escape. The gravitational pull of the entire core region is so immense that it acts as its own anchor, holding these stars in a tight, perpetual dance around the central void. This extreme environment is a potential breeding ground for exotic stellar objects that are incredibly rare in the calmer suburbs of galaxies like our own. The close proximity of so many stars drastically increases the probability of direct collisions and near misses, events that are astronomically unusual elsewhere. When two stars collide in such a dense environment, they can merge into a single, more massive star, a blue straggler that shines hotter and brighter than it should for its age. Repeated interactions could strip stars of their outer layers, leaving behind exposed stellar cores or creating bizarre binary systems locked in intensely tight orbits. Some theories even suggest that such environments are perfect for the formation of intermediate mass black holes, the elusive missing link between stellar mass black holes and the supermassive giants. A dense cluster of stars could, through a complex chain of collisions and mergers, eventually form a black hole hundreds or even thousands of times the mass of our Sun, an object that would then lurk unseen within the glittering heart of this already mysterious galaxy. Studying this compact core is like looking into a cosmic pressure cooker, allowing us to observe the outcomes of processes that unfold too slowly or too rarely to witness anywhere else. The sheer density of stellar bodies creates a natural laboratory for testing the limits of gravitational physics and stellar evolution under the most severe conditions. Each star in that crowded neighborhood feels the relentless tug of its countless neighbors, its path through space a complex calculation of innumerable gravitational influences. This environment could be producing stellar remnants and celestial objects that we haven't even classified yet, each one a testament to the violent and crowded beginnings of this fossil galaxy, and a clue to the strange physics that govern the most crowded places in the universe. Yet another profound mystery surrounding this ancient galaxy isn't about what it contains, but what it so conspicuously lacks. Every large galaxy we've ever studied, including our own Milky Way, is accompanied by a bustling entourage of smaller dwarf satellite galaxies. These are the cosmic minnows that swim in the gravitational wake of the Great Whale, often dozens or even hundreds of them, each a tiny galaxy in its own right that was captured eons ago and has been orbiting ever since. This isn't just a common feature. It's a fundamental prediction of our most successful model of the universe, the lambda cold dark matter model. The theory states that large galaxies form within immense halos of dark matter, and that smaller sub-halos of dark matter should naturally clump around them. These sub-halos are the nurseries where dwarf satellite galaxies are born and where they continue to orbit. So when astronomers pointed their telescopes at NGC 1277, they fully expected to find a similar swarm of tiny companions. Instead, they found a shocking void. The space around this colossal galaxy is eerily empty, devoid of the satellite galaxies that should, by all accounts, be there. It's like discovering a mighty king sitting entirely alone in his throne room, without a single courtier, guard, or servant in attendance. This absence is deafening. This missing entourage presents a serious challenge to our cosmological models. Where did they go, or more intriguingly, why were they never there in the first place? One possibility is that NGC 1277 has lived an existence of profound isolation. Perhaps it formed in a region of the early universe that was surprisingly devoid of the smaller density fluctuations that would normally collapse into dwarf galaxies. It emerged as a solitary giant in a cosmic desert, with no smaller neighbors to gravitationally capture. This would make it a true cosmic orphan, a lone monarch without a kingdom. Its journey through the Perseus galaxy cluster, which is itself a dense and chaotic environment, could provide another explanation. It's possible that the galaxy did once have a family of satellite galaxies, but the brutal gravitational forces within the cluster, a relentless tug of war between hundreds of large galaxies, stripped them all away. The satellite galaxies could have been torn from their orbits and flung into the intergalactic void, or perhaps they were entirely shredded and consumed by the cluster itself over billions of years. The most fascinating and radical explanation, however, once again ties back to the galaxy's other great mystery, its apparent lack of dark matter. If the dark matter halo around NGC 1277 is indeed missing or strangely configured, as the stellar motions suggest, then that would also explain the lack of satellites. Remember, it is the dark matter subhalos that provide the gravitational seeds for dwarf galaxies to form. No dark matter subhalos means no satellite galaxies. This absence, therefore, isn't just a curiosity. It could be powerful corroborating evidence for the other anomalous findings about this galaxy. It paints a consistent picture of a celestial object that somehow formed outside the standard rules, bypassing the conventional processes that govern every other galaxy we see. Its loneliness in space is a direct reflection of its profound abnormality, a silent testament to a formation history that remains hidden from us, challenging us to explain how a galaxy can be so massive and yet so utterly alone in the vast cosmic web. While the galaxy's core presents puzzles of gravity and absence, yet another layer of its mystery reveals itself not in visible light or radio waves, but in the high-energy realm of X-ray vision. Scattered throughout NGC 1277, astronomers have detected strange, point-like sources of X-ray emissions that defy immediate explanation. These aren't the familiar signatures of known celestial powerhouses. They don't match the predictable output of X-ray binary systems, where a star is being slowly consumed by a neutron star or stellar mass black hole. Nor do they align with the tremendous, chaotic roar of an active galactic nucleus being fed by its supermassive black hole. Instead, these are enigmatic beacons of high-energy light, suggesting that within this supposedly dormant fossil galaxy, unknown and powerful processes are secretly at work. The presence of these X-ray sources is particularly baffling given the galaxy's quiescent state. After its initial burst of star formation over 10 billion years ago, NGC 1277 is thought to have entered a long period of quiet retirement, its star-forming gas depleted and its central engine switched off. High-energy X-ray emissions are typically the hallmark of youth and violence, the birth cries of new stars, the death throes of massive ones, or the ferocious appetite of growing black holes. Finding them in such abundance here is like discovering a series of active, modern power plants inside a city that was abandoned centuries ago. It forces a profound question. What could possibly be generating such intense energy in a place where the primary engines of cosmic activity have been silent for eons? One compelling theory points to the possibility of a population of exotic binary systems that have evolved in isolation for billions of years. In the incredibly dense core of the galaxy, stellar encounters are far more common. It's possible that the gravitational dance of stars in this crowded environment has created unusual pairs, such as a white dwarf and a neutron star locked in a tight orbit. As the white dwarf spirals inward, pulled by the neutron star's immense gravity, its material could be violently ripped away and heated to millions of degrees upon impact, generating the observed X-rays. These would be rare and ancient systems, their evolution having followed a unique path due to the pristine conditions of their host galaxy, making them unlike any X-ray binaries we've cataloged elsewhere. An even more exciting possibility is that these X-ray sources are the long-sought signatures of intermediate mass black holes. These elusive objects, with masses ranging from a few hundred to a few 100,000 times that of our Sun, are a missing link in black hole evolution. While we have ample evidence for small black holes from dead stars and supermassive ones at galactic centers, the mid-sized category has been notoriously difficult to confirm. A handful of these black holes could be drifting through the galaxy, and as they occasionally accrete a wisp of gas or tear apart a passing star, they would flare up as bright X-ray sources for a brief period before fading back into obscurity. Their unusual output would be distinct from the larger supermassive black hole or smaller stellar mass ones, perfectly explaining the strange signatures we see. Perhaps the most intriguing explanation ventures beyond conventional astrophysics altogether. Could these X-ray emissions be an indirect signal of something even more exotic, like the presence and behavior of dark matter? Some theoretical models propose that dark matter particles, under certain conditions, can annihilate with their antimatter counterparts upon collision. This process would release a burst of energy, including high-energy gamma rays and X-rays. If dark matter is indeed concentrated in specific regions within NGC 1277, perhaps in clumps or a dense central halo, these annihilation events could manifest as the very point sources we detect. While highly speculative, this idea turns the galaxy's X-ray mystery into a potential window into the properties of the universe's most elusive substance, suggesting that this fossil galaxy might be hiding clues not just about stars and black holes, but about the fundamental nature of reality itself. Each unexplained X-ray photon is a piece of a puzzle, hinting that even in a galaxy frozen in time, the laws of physics may still be operating in ways we have yet to dream of. Now we arrive at a mystery that is felt rather than seen, a puzzle written in the very motion of the stars themselves. When astronomers measure the speed at which stars orbit within a galaxy, they are essentially taking the galaxy's gravitational temperature, a diagnostic test that reveals the total mass holding everything together. This measurement is called velocity dispersion, and in every other galaxy we've studied, it follows a predictable and understandable pattern. But for NGC 1277, the results are baffling. The stars are moving in ways that are completely inconsistent with the amount of mass we can actually see. Their velocities are far too high and chaotic, suggesting they are being whipped around by gravitational forces from an unseen source, a hidden hand guiding their motion that is not accounted for by the visible stars, gas, or even the central black hole. This velocity dispersion anomaly creates a direct and profound conflict with other observations of this galaxy. On one hand, the high speeds of the stars suggest there must be an enormous amount of mass present to prevent them from simply flying off into intergalactic space. This would typically be the signature of a massive, unseen dark matter halo, the very gravitational anchor we expect to find. Yet, when we look at the broader rotation of the galaxy as a whole, the story changes. The overall rotation curve, which charts how orbital speeds change with distance from the center, doesn't show the classic flat profile that is the hallmark of a dark matter-dominated galaxy. Instead, it declines, much like you would expect if the visible matter were all there is. So we are left with a maddening contradiction. The local, internal motions of stars scream that there is extra mass, while the global rotation of the galaxy whispers that there is not. It's as if the galaxy is giving us two different answers to the same fundamental question, and both cannot be true under our current laws of physics. This discrepancy forces astronomers to consider some truly extraordinary possibilities. One compelling theory is that the dark matter in NGC 1277 is not missing, but is instead distributed in a radically different way than in any other galaxy we've catalogued. Instead of being spread out in a vast spherical halo, it might be concentrated in a dense, disk-like structure that is aligned with the galaxy's own stellar disk. In this scenario, the dark matter would be right there among the stars, its gravitational influence strongest in the crowded central regions where we see the confusing stellar velocities, but its effect on the outer rotation of the galaxy would be minimal. This would be a completely new configuration for dark matter, suggesting that it can behave in more complex ways than our simple halo models allow, perhaps even interacting with itself or with the ordinary matter in ways we haven't yet dreamed of. Another fascinating explanation looks not to hidden matter, but to the galaxy's unique history for answers. Recall that NGC 1277 is a relic, a galaxy that formed quickly and then stopped. It's possible that the stellar orbits we see today are not in a state of equilibrium. They could be the frozen echo of a violent event that occurred billions of years ago, a gravitational trauma that sent stars careening on unusual paths that have not yet had time to settle down. Perhaps the galaxy experienced a near miss with another large object in the distant past, a gravitational tidal shock that stirred up the orbits without triggering a full merger. In a galaxy that has been otherwise dormant for eons, such a disturbance would leave a lasting imprint on the motion of the stars, a fossilized record of chaos that we are misinterpreting as evidence for dark matter in the present day. Ultimately, the velocity dispersion puzzle is a powerful reminder that our understanding of the cosmos is built on inferences and models. We cannot touch dark matter or see a gravitational field. We can only observe their effects on the things we can see, like stars. When those effects contradict each other, as they do here, it is a clear sign that our models are incomplete. This single galaxy, with its strangely moving stars, is challenging us to think more creatively about the invisible forces that shape the universe, pushing us to either discover a new form of dark matter or to finally grasp a deeper truth about the nature of gravity itself. While the motion of stars and the emission of X-rays reveal hidden forces and energetic processes, another layer of NGC 1277's mystery unveils itself in the warmth of invisible light. Peering into the galaxy with instruments sensitive to infrared radiation, astronomers have pinpointed several strange, glowing points of light that defy classification. These aren't the familiar signatures of cool, aging stars or the gentle warmth of vast, quiet dust clouds. Instead, they are brilliant, compact sources of infrared energy with a spectral fingerprint that doesn't match any known type of celestial object in our cosmic library. It's as if we've tuned into a radio station and found a frequency broadcasting a type of music we've never heard before, with instruments we cannot even name. These unidentified infrared objects represent a blank spot on our map of the cosmos, suggesting the existence of phenomena or entire classes of objects that have, until now, remained hidden from our view. The infrared spectrum is typically the domain of the cool and the hidden. We use it to see through obscuring veils of dust to witness the birth of new stars, or to study the faint glow of the oldest, coldest stars in a galaxy. But the sources found in NGC 1277 are anomalous because they are both intense and isolated. They shine with a power that suggests a significant energy source, yet they are not associated with the chaotic regions of star formation or the violent environs of the galactic center. Their very presence in this fossil galaxy is a conundrum. If they were young, hot stars embedded in dusty cocoons, we would expect to see other signs of recent star formation around them, but we see none. If they were distant background galaxies magnified by gravitational lensing, their specific infrared signature wouldn't align with known galactic types. They are spectral ghosts, detected clearly but understood poorly. One compelling hypothesis for these warm enigmas involves the possibility of ancient, failed stars shining in a new light. Imagine a population of cold, dark stellar remnants like brown dwarfs or white dwarfs that have drifted through the galaxy for billions of years. If one of these dark objects were to pass through a rare, dense patch of interstellar gas and dust, its gravity could pull material onto its surface. As this matter accretes, it would compress and heat up, suddenly causing the otherwise invisible object to flare with intense infrared radiation. In a galaxy as old and pristine as this one, such an event would be incredibly rare, but the sheer timescale involved means that even the most improbable occurrences might eventually happen, presenting us with a brief, warm glow from a usually dark object. An even more exotic possibility is that we are seeing the signature of a rogue planetary system meeting its end. A gas giant planet, flung from its star system by a gravitational encounter in the distant past, could still retain a thick, warm atmosphere. If this lonely world were to collide with a vast, diffuse cometary cloud in the interstellar depths, the tremendous energy of the impact could vaporize the icy material, creating a temporary, warm shell of gas and dust around the planet that glows brightly in the infrared for centuries before fading away. This would be a one-in-a-billion event, a catastrophic accident frozen in time and preserved in the fossil record of this ancient galaxy for us to discover. Perhaps the most thrilling explanation is that these points of light are evidence of something entirely new. They could be a previously unobserved class of mid-sized black holes, larger than a star but smaller than the galactic core behemoth, that are actively accreting a thin wisp of material and radiating the energy away as heat. Or they might be the aftermath of a stellar collision, a rare event made more probable by the galaxy's densely packed core, where two stars crashed together in the relatively recent past, creating a single, hot, and massive new object shrouded in a brilliant veil of warm debris. Each unidentified source is a beacon pointing toward a potential discovery that could add a new entry to our astronomical field guides, proving that even after centuries of observation, the universe still holds profound surprises in the most unexpected places. Delving into the elemental heart of this fossil galaxy reveals a chemical signature so strange it reads like a secret message from the early universe. When astronomers break down the light from NGC 1277 stars, they can identify the precise cocktail of elements present, and what they find is a distribution of heavy elements that defies all expectations. In every other galaxy we've studied, from our own Milky Way to distant spirals, the relative abundances of elements like oxygen, magnesium, and iron follow a predictable pattern, a cosmic recipe that has been consistently followed for billions of years. These patterns are the direct result of nucleosynthesis, the process by which elements are forged inside stars and then scattered across space by supernova explosions. But here, the recipe has been altered. The ratios of these key elements are off, showing anomalies that suggest the processes that created them were fundamentally different from the well-understood pathways we observe everywhere else in the cosmos. This chemical fingerprint points to a universe where the rules of stellar physics were not yet set in stone. One of the most striking anomalies involves the ratio of magnesium to iron. In younger galaxies, these two elements maintain a specific balance, with iron being more abundant due to its production in a specific type of supernova explosion from white dwarf stars. However, in NGC 1277, magnesium is significantly overabundant compared to iron. This single detail is a massive clue, because magnesium is primarily synthesized in the violent deaths of extremely massive, short-lived stars, the kind that would have dominated the very first generations of star formation. The high magnesium-to-iron ratio suggests that this galaxy's chemical enrichment was dominated almost entirely by these colossal, primordial supernovae, and that the later, iron-producing explosions were strangely absent or suppressed. It's as if the galaxy's chemical clock stopped ticking after the first few notes, preserving a purer, more primal elemental composition than anywhere else we've ever seen. This anomaly forces us to reconsider the very nature of the first stars. The Standard Model suggests that the earliest stellar generations were not only massive but also incredibly pure, composed almost entirely of hydrogen and helium. Their supernova would have been far more energetic than anything we see today, and their nucleosynthesis pathways could have been drastically different, potentially producing a unique mix of elements that was never replicated in later, more polluted cosmic environments. NGC 1277, having shut down its star formation so early, effectively captured and preserved the output of these first fantastic explosions. Its stars are not just metal poor. They are painted with the unique and strangely proportioned palette of the universe's first artists. Studying this chemical imbalance is like discovering a pristine cave painting that uses colors and techniques lost to history, offering us an unparalleled glimpse into the chaotic and creative forge of the cosmos's infancy. The implications of this chemical oddity stretch far beyond this single galaxy. If the nucleosynthesis processes in the early universe were indeed different, it means our models for how all the elements in our bodies and our world were created might be incomplete. We base our understanding of cosmic chemical evolution on the patterns we see in galaxies that have continued to evolve. But this relic galaxy, suggests that the early universe operated under a slightly different set of physical rules or conditions. Perhaps the stars were more massive on average, or their explosions were more efficient at producing certain elements. Unraveling this chemical mystery doesn't just solve a puzzle about one ancient galaxy. It refines our entire story of where we came from, revealing that the elements that make up our very being were forged in a more diverse and mysterious set of cosmic furnaces than we ever imagined. Now, as we turn our gaze to the faint, flickering lights within this ancient galaxy, we encounter a mystery that plays out over time itself. Scattered across the expanse of NGC 1277 are points of light that refuse to shine with a steady, constant glow. These are not the predictable, rhythmic pulses of known variable stars, whose brightness ebbs and flows like a perfectly tuned metronome due to periodic swelling and shrinking. Nor do they match the violent, chaotic flickering of material screaming into an active black hole. Instead, these objects exhibit a strange, irregular optical variability, flaring up and dimming down in a seemingly random and unpredictable pattern that has astronomers utterly perplexed. It's as if someone is randomly turning a dimmer switch up and down on these cosmic light bulbs, with no discernible schedule or reason, creating a pattern of light that defies all known classification. This erratic behavior is a significant clue that we might be looking at an entirely new class of celestial object. Consider a Cepheid variable star, one of the standard candles we use to measure cosmic distances. Its pulsations are so regular you could set your watch by them, caused by well-understood internal processes of expansion and contraction. The objects in NGC 1277 share none of that regularity. Their changes in brightness are stuttering, chaotic, and unique, suggesting the underlying mechanism is something far more exotic and less stable. One compelling theory points to the possibility of a previously unseen type of binary system, perhaps involving a neutron star with an incredibly powerful magnetic field, a magnetar, locked in a tight orbit with a companion star. As the magnetar spins, its immense magnetic field could interact with the stellar wind of its partner in complex and unstable ways, periodically channeling material and generating massive, irregular flares that we see as sudden surges in brightness. Another fascinating possibility involves the concept of a zombie star system, a cosmic entity that should be dead but is periodically reanimated. Imagine a white dwarf, the cold, dense core of a dead star, drifting through a region rich in debris left over from the galaxy's violent youth. If this stellar remnant occasionally plows through a particularly dense cloud of this ancient dust and gas, the sudden accretion of material could trigger a temporary reignition of nuclear fusion on its surface. This would cause the dead star to flare back to life with a brilliant and unpredictable burst of light before fading away again, a ghostly flicker in the galactic fossil record. The pristine, untouched nature of NGC 1277 means such ancient debris fields could still be intact, making this kind of rare event more likely to occur and be observed. The most thrilling explanation, however, is that this irregular variability is our first glimpse of a theoretical object finally revealing itself. For decades, astrophysicists have speculated about the existence of intermediate mass black holes, but conclusive evidence has been elusive. One of these mid-sized black holes wandering through the galaxy could be occasionally snatching and tearing apart small, passing objects like asteroids or comets. Each time it consumes a morsel of matter, the tidal disruption event would create a short-lived, flaring accretion disk that shines brightly before quickly vanishing, resulting in the exact kind of unpredictable optical variation we detect. The random timing of these snack attacks would produce a light curve unlike any other, a signature of a hidden predator slowly grazing its way through the ancient stellar population. Each mysterious flicker of light is therefore a potential signal, a breadcrumb trail leading us toward a deeper understanding of the hidden inhabitants of this cosmic relic and the strange, time-dependent physics that govern them. This cosmic drought presents us with one of the most fundamental mysteries surrounding this galactic fossil. How does a galaxy lose its very lifeblood? For a galaxy to become a relic, it must be starved of the cold, neutral hydrogen gas that is the raw material for new stars. In the case of NGC 1277, this starvation appears to have been absolute and permanent. While other galaxies continually siphon fresh gas from intergalactic space or acquire new reservoirs through collisions, this ancient galaxy has been left with an empty tank, its star-forming engines silent for over 10 billion years. The complete absence of this neutral hydrogen is the definitive reason it became a frozen relic. But the mechanism behind this galactic-scale dehydration is what truly baffles scientists. It's as if a vast ocean has somehow completely vanished, leaving behind only a dry, empty basin and no clear explanation for where the water went. Several compelling theories attempt to solve this puzzle, each one painting a picture of a dramatic and violent past. One leading idea points the finger directly at the galaxy's own monstrous core. As the supermassive black hole gorged itself on matter during the galaxy's frantic youth, it would have unleashed a devastating torrent of energy. Powerful jets of particles and intense radiation could have blown the remaining reservoir of neutral hydrogen clear out of the galaxy, like a cosmic hurricane scouring a landscape of all its moisture. This process, known as quenching, is thought to happen in many galaxies, but in NGC 1277, it must have been exceptionally efficient and complete, leaving not a single wisp of star-forming gas behind. The black hole essentially sterilized its own home, shutting down its future in a single, catastrophic outburst. Another possibility involves the galaxy's environment. NGC 1277 is not a true hermit. It orbits within the immense Perseus galaxy cluster, a crowded metropolis of galaxies swimming in a superheated plasma known as the intracluster medium. As the galaxy hurtles through this thin, scorching gas at millions of miles per hour, it would experience a phenomenal pressure, a cosmic version of the wind you feel sticking your hand out of a car window, but on an unimaginable scale. This ram pressure could have effectively stripped the galaxy of its neutral hydrogen, ripping the gas away from its gravitational embrace. It's a process akin to a powerful stream of water blasting dust off a speeding car, leaving the vehicle polished but empty. The galaxy's high speed through the cluster would have made it particularly vulnerable to this form of interstellar robbery, potentially explaining the thoroughness of the gas loss. There is, however, a third and even more intriguing possibility, that the galaxy never had much neutral hydrogen to begin with. Its initial, incredibly rapid burst of star formation may have been so voracious that it consumed nearly 100% of the available primordial gas in one go. A single feast that left no leftovers for a later meal. In this scenario, the galaxy didn't lose its gas. It simply used it all up in one glorious, unsustainable firestorm of creation. This would make NGC 1277 a cosmic example of live fast, die young. A galaxy that burned with incredible brilliance for a short time and then faded into a permanent, quiet retirement, its potential exhausted in a single epic burst. The absence of neutral hydrogen isn't a mystery of loss, but a signature of astonishing and complete efficiency. A testament to a formative era of the universe when the rules of galactic construction allowed for such extreme and definitive outcomes. Now we turn our attention to a phenomenon that represents the beautiful and final act of a star's life. But in this galaxy, even death seems to follow a different script. Throughout the cosmos, when sun-like stars reach the end of their fuel supply, they don't go quietly. They shed their outer layers into space, creating magnificent, glowing shells of illuminated gas known as planetary nebulae. These cosmic butterflies are typically found scattered throughout a galaxy's disk, their distribution and chemical makeup telling a consistent story of stellar life cycles. But within NGC 1277, this story takes a bizarre and unexpected turn. The planetary nebulae here are not distributed in the way we would predict at all. Instead of being spread evenly or following the density of the older stellar population, they show a strange and clumped spatial arrangement, gathered in groups that defy simple explanation, as if the stars that created them all decided to die in the same neighborhoods at the same time. Even more telling than their unusual location is their very soul, their chemical composition. When astronomers analyze the light from these glowing shells, they find an elemental fingerprint that is markedly different from planetary nebulae in any other galaxy. They are significantly more deficient in heavy elements than they should be, even for this metal-poor galaxy. This is profoundly strange because the process that creates a planetary nebula is also the primary mechanism by which a galaxy is enriched with newly forged heavy elements. A dying star dredges up material from its interior carbon, nitrogen, oxygen, and flings it out into space, seeding the next generation of stars and planets. The extreme metal poverty of these nebulae suggests that the stars that created them had almost no heavy elements to dredge up in the first place. Their deaths were chemically quiet affairs, returning to the galaxy a nearly pristine mixture of hydrogen and helium, barely altered from the primordial gas from which they were born 10 billion years ago. This anomaly paints a startling picture of stellar evolution in isolation. It suggests that the stars in NGC 1277 not only formed from unpolluted gas, but lived and died without the complex internal chemical processing we see in stars from younger galaxies. Their evolution may have followed a more direct and simpler pathway, one that was cut short or streamlined by the absence of metals that normally act as catalysts for various nuclear reactions in a star's core. The unusual distribution of these nebulae adds another layer to the puzzle. Their clumped arrangement could be a fossilized record of the galaxy's initial star-forming regions. Perhaps all the stars born in one particular dense cloud of gas lived, and then died on similar timescales, their planetary nebulae now marking the ghostly outline of that ancient stellar nursery. In a galaxy that never experienced the mixing and stirring of mergers, these original birth clusters could have remained intact, their stellar populations living and dying together as a single, coherent family, leaving behind a grouped pattern of death that has been frozen in time for eons. But just as the galaxy reveals its secrets through the faint glow of dying stars, it also whispers of even more violent and energetic processes emanating from its ancient heart. Nestled within specific regions of NGC 1277, astronomers have detected a faint, persistent, and utterly puzzling signature of gamma-ray light. This is the highest energy form of light in the universe, typically generated by the most cataclysmic events imaginable: the crushing collisions of neutron stars, the relativistic jets screaming from active black holes, or the annihilating fury of matter meeting antimatter. Yet the gamma rays coming from this fossil galaxy don't match the profile of any known source. They are not the focused, lighthouse-like beam of a spinning pulsar, nor are they the chaotic roar from a jet powered by an accreting supermassive black hole. Instead, they present as a faint, diffuse, and stubbornly persistent glow, a cosmic background hum of ultra-high-energy radiation that has no clear origin story, making it one of the most enigmatic signatures we have yet encountered. The mere presence of such emissions is a profound paradox. Gamma rays are the hallmark of extreme violence and youth, the birth cries of new neutron stars or the death screams of massive stars. Finding them in a galaxy that has been dormant for 10 billion years is like detecting radiation in an ancient, sealed tomb. It suggests that some incredibly powerful engine is still active, or that the aftermath of a long-past event is still reverberating through the cosmos in a way we don't understand. This isn't a signal that fits neatly into our catalogs of celestial objects. It's an anomaly that points toward processes or objects that may have been common in the early universe, but have since faded from view everywhere else, preserved here in this cosmic time capsule. One compelling theory to explain this persistent gamma-ray glow involves the possibility of a vast population of ancient millisecond pulsars. These are neutron stars that have been spun up to incredible speeds by accreting matter from a companion star, and they can emit powerful gamma-ray radiation. In the densely packed core of NGC 1277, such objects could have formed in the distant past and now drift silently, their gamma-ray emissions combining into a faint, collective hum that permeates the central regions. This would be a population of stellar corpses from the galaxy's frenzied youth, still shining in the highest energies long after their optical light has faded into obscurity, their combined output creating a signature we are only now sensitive enough to detect. A more exotic and thrilling possibility is that these gamma rays are the first indirect evidence of dark matter annihilation. Certain theoretical models propose that dark matter particles could be their own antimatter counterparts. If two of these particles were to collide, they would annihilate each other in a flash of energy, producing gamma rays among other particles. If NGC 1277 does indeed possess a dense, concentrated clump of dark matter at its core, as suggested by the gravitational lensing anomaly, this could be the perfect environment for such annihilations to occur at a detectable rate. The faint, pervasive glow would then be the shimmer of invisible matter slowly destroying itself, a process playing out over billions of years and offering us a potential window into the properties of the universe's most mysterious substance. This single, faint signal could therefore be the key to unlocking one of cosmology's greatest mysteries, hidden in plain sight within the light of an ancient galaxy. Yet another fascinating explanation looks to the galaxy's unique history for answers. The incredibly rapid and efficient initial burst of star formation would have produced a tremendous number of massive stars, all living short, violent lives and dying in supernova explosions. The sheer concentration of these events in a relatively small volume of space and a short period of time could have created a lingering and complex ecosystem of high-energy particles and magnetic fields. Shock waves from these ancient explosions might still be propagating through the tenuous interstellar medium, accelerating protons and electrons to near light speed. When these relativistic particles collide with photons or other atoms, they can produce gamma rays. In this scenario, the gamma-ray glow is the fading echo of the galaxy's own dramatic birth, a fossilized energy field that has persisted for eons, a permanent reminder of the incredible violence that gave rise to this otherwise quiet relic. Each unexplained gamma-ray photon is thus a messenger from that primordial era, carrying a story of creation and destruction that we are only just beginning to learn how to read. Now we turn our attention to objects in motion, to the silent trajectories of stellar bodies that trace a hidden history across the void. Astronomers tracking the individual movements of star systems within NGC 1277 have pinpointed several that are behaving in ways that simply don't add up. These are the strange proper motion objects, suns and their potential entourages that are moving with speeds and directions that cannot be reconciled with the gravitational map of the galaxy as we understand it. Their paths are anomalous, suggesting they are being propelled by forces far beyond the gentle tug of the galaxy's overall mass, almost as if they were fired from a cosmic cannon in the distant past, and are now coasting on a trajectory that defies conventional explanation. Proper motion is the subtle, real movement of a star across our line of sight, a slow drift against the backdrop of more distant stars. In a stable, predictable galaxy, these motions follow the rules set by gravity's invisible hand. But for these specific objects, the rules appear to have been broken. Their velocities are too high, their angles of travel are askew from the orderly rotation of the galactic disk, and their paths cannot be traced back to any known gravitational source within the galaxy. It's as if you were watching a flock of birds flying in a perfect formation, and then suddenly noticed a few individuals breaking away at incredible speed, moving in a direction that no wind current could possibly account for. These stellar systems are the renegades, The outliers whose motion tells a story of a violent and disruptive event that occurred eons ago. One compelling theory for these runaway objects involves a dramatic gravitational slingshot event centered on the galaxy's monstrous central black hole. Imagine a binary star system, two stars locked in a mutual orbit, venturing too close to the immense gravitational well at the galaxy's heart. The black hole's gravity could have captured one star, pulling it into a tight orbit, while violently flinging its companion away at a tremendous velocity, ejecting it from the central region entirely. This process, known as the Hill's mechanism, could explain how a star or even an entire compact stellar system could be given a powerful kick, sending it on a high-speed journey through the galaxy on an inexplicable path. The energy for this launch comes from the binary star's own orbital energy, harnessed and redirected by the black hole's gravity in a celestial game of capture and release. However, the sheer number and specific trajectories of some of these objects suggest an even more extraordinary possibility. Could we be witnessing the aftermath of an ancient, intermediate-mass black hole being ejected from the galaxy's core? If a second, smaller black hole had once orbited the primary one, their eventual merger would have been so violent that the resulting gravitational wave recoil could have kicked the newly combined black hole clear out of the galactic center. Any stars that were closely orbiting this intermediate black hole would have been carried along with it, like passengers on a runaway ship, now drifting as a cohesive but leaderless group through the galaxy with a strange, shared proper motion that points back to their point of origin. This would manifest as a cluster of stars all moving in the same unusual direction, a ghostly parade following an invisible gravitational master. The most fascinating implication of these anomalous motions is that they might provide indirect evidence for the very thing that seems to be missing: dark matter. If the distribution of dark matter within NGC 1277 is indeed bizarrely lumpy or concentrated, as some theories suggest, then the gravitational tug from these invisible clumps could be subtly influencing the paths of these stars, pulling them off their expected courses. We wouldn't see the source of the gravity, we would only see its effect on the visible matter, much like seeing leaves swirl in a pattern that hints at the presence of a rock in a stream that we cannot see below the surface. These strange proper motions could therefore be the first clues mapping the hidden, and strangely configured, dark matter skeleton of this fossil galaxy. Each inexplicable trajectory is a data point in a much larger puzzle, a whisper of forces both seen and unseen that have shaped this galaxy's long and isolated history. Deep within the swirling starlight of this ancient galaxy, astronomers have mapped structures that should not exist, delicate filaments of cosmic dust that defy our expectations of how such material behaves. These are not the uniform, well-mixed dust lanes we see in younger galaxies like our own Milky Way, where dust is constantly being recycled and reprocessed by new generations of stars. Instead, the dust lanes in NGC 1277 show a bizarre and patchy distribution, with stark variations in temperature and composition across surprisingly small distances. Some regions are shockingly cold, barely a few degrees above absolute zero, while adjacent filaments are significantly warmer, creating a thermal mosaic that has no clear explanation. This isn't just a minor curiosity, it's a fundamental clue that the very nature of dust itself, and the processes that formed it, were radically different in the primordial universe that this galaxy encapsulates. The composition of this ancient dust adds another layer to the puzzle. When analyzed spectroscopically, it reveals a startling lack of complex silicate and carbon-based grains, the common soot and sand that make up the bulk of dust in the modern cosmos. Instead, the dust here appears to be dominated by simpler, more refractory materials, like certain metallic oxides and glasses, which can form at much higher temperatures. This unique chemical fingerprint points to a singular, violent origin story. The dust in NGC 1277 wasn't slowly built up over eons through the gentle outflows of aging stars. It was likely forged in the incredible heat and pressure of the galaxy's initial, ferocious wave of supernova explosions, all occurring within a very short window of time. These cataclysmic events would have vaporized existing materials and then rapidly condensed them into new, exotic types of grains in the expanding shock waves, a process far more extreme than the steady dust production we see today. This anomaly forces a profound shift in our understanding of cosmic recycling. In a typical galaxy, dust is constantly being destroyed by radiation and shock waves, and then reformed in the atmospheres of cool, aging stars, creating a continuous cycle that gradually enriches the dust with increasingly complex compounds. But NGC 1277's dust cycle was frozen in its infancy. The galaxy's abrupt shutdown of star formation meant that this second, gentler method of dust production was almost entirely absent. The dust we see today is therefore a direct relic of those first, fantastic explosions, a preserved sample of the universe's earliest solid materials. Its unusual thermal behavior, the strange hot and cold spots, could be a direct result of this simple composition. Without more recent, fluffy carbon compounds to act as insulating material, the dust grains may absorb and radiate heat with much less efficiency, leading to the wild temperature swings observed as they are unevenly heated by the faint, ancient starlight. Studying these pristine dust lanes is like being handed a sample of the universe's first ceramics, unaltered by 10 billion years of weathering. It provides a critical baseline for understanding how the complex dust grains that form planets and life itself eventually came to be. The peculiarities of this fossil dust suggest that the early universe was a much more extreme environment for the formation of solid matter, capable of manufacturing types of dust that no longer exist elsewhere. This isn't just a snapshot of the past. It's a window into an alternate pathway of cosmic evolution, showing us what the building blocks of planets might have looked like if the universe had never progressed beyond its first, furious chapter of creation. Now we shift our gaze to the high-energy end of the spectrum, where the galaxy reveals yet another layer of its profound mystery through the searing light of ultraviolet radiation. Scattered across the ancient expanse of NGC 1277, astronomers have pinpointed several intensely bright and compact sources of ultraviolet light. This discovery is particularly baffling because the ultraviolet part of the spectrum is typically the domain of youth and extreme heat. It's the brilliant glare of newborn, massive stars, or the ferocious energy pouring from the accretion disks of actively feeding black holes. But in a galaxy that has been dormant for over 10 billion years, a place where star formation ceased in the distant past, and the central supermassive black hole has long been quiet, such powerful and localized ultraviolet emissions simply should not exist. Their presence is like finding a series of blast furnaces operating at full tilt inside a city that has been abandoned for millennia. It defies all logical explanation and points to physical processes we have not yet begun to understand. What makes these ultraviolet sources so enigmatic is their spectral signature. They don't match the clean, predictable output of any known type of celestial object. If they were clusters of hot, young stars, we would see the telltale signs of surrounding nebulosity and evidence of recent star birth in their immediate vicinity, but we see none. If they were the fading embers of a once active galactic nucleus, their energy distribution across different wavelengths would follow a specific pattern, which it does not. Instead, these objects present a unique and puzzling ultraviolet fingerprint, suggesting they are either an entirely new class of ultraviolet-emitting object or a known type of object behaving in a radically new way due to the pristine, ancient environment of this fossil galaxy. They are brilliant, anonymous beacons of high-energy light shining from a place of profound cosmic quiet, and their very existence challenges our catalog of what is possible in the universe. One compelling hypothesis for these mysterious ultraviolet furnaces involves the possibility of a population of exotic and evolved stellar remnants. Imagine a white dwarf, the Earth-sized core of a dead star, with a surface temperature soaring into the hundreds of thousands of degrees. While most white dwarfs cool steadily over billions of years, a rare few might experience a temporary reignition. If such a dense remnant were to gravitationally capture and consume a large amount of material from a passing gas cloud or a binary companion, the sudden influx of fresh hydrogen could trigger a runaway thermonuclear explosion on its surface. This event would cause the white dwarf to flare with intense ultraviolet radiation for a relatively short cosmic period before settling back into dormancy. In a galaxy as old and undisturbed as this one, such an accretion event, while incredibly rare, would stand out as a brilliant and unexplained point of ultraviolet light. An even more fascinating possibility is that we are witnessing the signature of a stellar collision that occurred in the relatively recent past. In the densely packed core of NGC 1277, the close gravitational dances between stars make direct impacts more likely than in calmer galaxies. If two white dwarfs were to collide and merge, the catastrophic event would create a single, massively oversized object that could briefly ignite fusion in its core, shining with the intense heat and ultraviolet brilliance of a newborn star, a phoenix rising from the ashes of two stellar corpses. This merged object would be a bizarre and short-lived phenomenon, a temporary sun shining with the light of an event that happened long after the galaxy's main era of star formation had ended, its ultraviolet glow a testament to the violent and unpredictable dynamics that can still occur in even the most ancient of stellar cities. Perhaps the most thrilling explanation is that these ultraviolet sources are our first evidence of a theoretical type of black hole finally revealing itself. An intermediate mass black hole with a mass of a few thousand suns would be too small to power the vast energy output of a galactic nucleus, but far larger than a typical stellar mass black hole. If one of these elusive objects were drifting through a region rich in interstellar gas, its immense gravity could pull in a steady stream of material. As this gas spirals inward at a significant fraction of the speed of light, it would compress and heat up to millions of degrees, generating a brilliant and compact point of extreme ultraviolet radiation. The unique environment of this Relic galaxy, with its unusual gas properties and lack of contaminating energy sources, might allow this specific signature to be seen clearly for the first time, turning each mysterious ultraviolet source into a potential flag marking the location of one of cosmology's most sought-after missing links. Orbiting silently through the dense and violent environment of the Perseus galaxy cluster for billions of years, NGC 1277 presents us with a profound and telling void, the complete and utter absence of any tidal streams. In the cosmos, galactic interactions are not the exception, they are the rule. When galaxies brush past one another or collide in a slow-motion gravitational dance, they don't emerge unscathed. Their mutual gravity pulls and stretches them, ripping out long, graceful arcs of stars, gas, and dust that are flung into intergalactic space. These are tidal streams, the glittering scars and debris trails that bear witness to a galaxy's dynamic and often violent social life. They are the cosmic equivalent of finding strands of hair on a sofa, undeniable evidence that company has been over. In a massive cluster like Perseus, which is teeming with hundreds of galaxies all pulling at each other, these stellar streams should be everywhere, a tangled web of past encounters. Yet, when we look at NGC 1277, we find none. Its surroundings are pristine, its borders sharp and clean. There is no evidence it has ever had a close encounter of any significance. This absence is a deafening silence, a powerful testimony to its incredible isolation, but it also deepens the mystery of how such a thing was even possible. This lack of tidal debris is one of the strongest pieces of evidence supporting its classification as a true relic galaxy. It confirms that NGC 1277 has not just been quiet internally. it has been a cosmic hermit externally as well. It has managed to avoid the gravitational handshakes, the mergers, and the near misses that reshape and redefine every other galaxy of its size. Think of it as a priceless antique vase that has been displayed in a bustling home full of children and pets for centuries, yet remains perfectly perched on its shelf without a single chip, scratch, or fingerprint. The odds of such preservation are astronomically low. This pristine state means that the properties we measure today, the metal-poor stars, the ancient globular clusters, the bizarre black hole, are not a messy amalgamation of multiple histories. They are the original, unaltered features from its birth, giving us a perfectly clear window into the conditions of the early universe without the blurring effect of later additions. The question this absence forces us to ask, however, is not just what it means, but how it was achieved. How does a galaxy as massive as this one sail through the most crowded neighborhood in the local universe for over 10 billion years without a single scrape? The Perseus cluster is a gravitational battlefield, a region where tidal forces are immense and relentless. For NGC 1277, to have no tidal streams suggests one of two extraordinary scenarios. The first is that it has lived a life of incredible luck and precision, navigating the chaotic cluster environment like a master sailor, always finding the calm channels between the gravitational storms. It may have spent most of its existence orbiting in the quieter outskirts of the cluster, only recently falling toward the crowded center, thus avoiding the prolonged harassment that would have stripped its stars and left behind telltale streams. The second, more fascinating possibility is that its unique physical properties themselves provided a form of protection. Recall that this galaxy is incredibly compact and massive for its size, with an unusually high stellar density. It is a cosmic cannonball. When a less dense galaxy interacts with the cluster environment, it is like a pillow being pulled apart. It leaves a fluffy trail of material everywhere. But a cannonball fired through the same space would hardly shed a splinter. NGC 1277's immense density and rapid orbital speed through the cluster may have made it resistant to tidal stripping. The gravitational forces trying to pull it apart simply weren't strong enough to overcome the intense pull of its own gravity, which held its stars in a vise-like grip. Its compactness became its armor, allowing it to plunge through the cluster's heart without losing a single star, leaving no evidence of its passage and preserving its pristine, ancient state against all odds. This void of debris is therefore not just an absence. It is a positive signature of a galaxy built differently from the very beginning, forged in the early universe to be a permanent and unchanging monument to its own creation. Moving deeper into the stellar population of this ancient galaxy, we encounter a subtle but profoundly telling pattern hidden within the relationships between its stars. While most galaxies are filled with countless binary systems, pairs of stars locked in a gravitational dance, the binaries in NGC 1277 are not like the ones we know. They tell a different story, one written in the language of mass ratios and orbital distances. In younger galaxies like our Milky Way, binary stars tend to follow certain predictable rules. You often find pairs where the two stars are of similar mass, like twins, orbiting each other at a comfortable distance. Alternatively, you might find a system with a large mass difference, like a Sun-like star paired with a small red dwarf. But in this Relic galaxy, the statistics are skewed. There is a strange overabundance of binary pairs with extreme, lopsided mass ratios, and a surprising number of systems where the stars orbit each other at distances that are either unusually close or strangely far apart. This isn't a random distribution. It's a signature, a fossilized record of a time when the rules of stellar courtship were fundamentally different. This abnormal binary census points directly back to the unique environmental conditions of the early universe. Stars form from the collapse of dense clouds of gas and dust, and the properties of that parental cloud dictate the outcome. In the primordial gas cloud that gave birth to NGC 1277, the lack of heavy elements and the incredible density would have influenced how these stellar nurseries fragmented. Without the complex chemistry and cooling effects provided by metals, the cloud may have broken apart into clumps of different sizes and densities than we see in modern star-forming regions. This could have preferentially produced systems where one star formed from a large, dominant clump of gas, while its companion accreted from a much smaller, leftover fragment, naturally leading to these pairs with wildly different masses. The sheer density of the birth environment also plays a role. In a more crowded nursery, gravitational interactions between young stellar systems can dramatically alter their orbits, either pulling pairs much closer together or flinging them much farther apart in a chaotic game of cosmic pinball. The significance of this discovery extends far beyond cataloging strange star pairs. Binary systems are the cosmic laboratories for some of the most dramatic events in the universe, including the Type 1, a supernova we use as standard candles to measure cosmic distances. These supernovae occur when a white dwarf star steals enough material from a companion to trigger a catastrophic explosion. The precise nature of that explosion, and therefore the brightness of the resulting supernova, depends critically on the properties of the binary system, particularly the masses of the two stars and their separation. If the binary populations in the early universe were statistically different, as they are in NGC 1277, it means these ancient supernovae may have behaved differently than their modern counterparts. This raises a tantalizing and slightly unsettling question. Could our measurements of the universe's expansion, which rely on the consistent behavior of these supernovae across cosmic time, have a subtle systematic error buried within them? This fossil galaxy's unusual binaries suggest that the very tools we use to map the cosmos may need to be carefully recalibrated when looking back to the earliest epochs, reminding us that our constants might not be so constant after all. Now we arrive at a mystery woven into the very fabric of space itself, an invisible force that reveals just how unique this cosmic relic truly is. Most large galaxies, including our own Milky Way, possess a magnetic field, a kind of cosmic fingerprint generated by the churning motion of conductive gas and the dynamo effect of star formation and supernova. These fields are typically chaotic, tangled webs, a messy byproduct of billions of years of continuous stellar activity and galactic turmoil. But when astronomers finally managed to map the magnetic field of NGC 1277, they found something that defied all expectations. Instead of a disorganized snarl of magnetic force lines, they detected an incredibly organized and large-scale structure, a magnetic field with a surprising degree of coherence and order that stretches across vast stretches of the galaxy. This isn't the chaotic scribble of a toddler. It's the deliberate, elegant signature of a master architect, a pattern of forces that simply shouldn't exist in a galaxy of this age and type. The presence of such a well-ordered magnetic field is a profound puzzle because magnetic fields are not static. They are dynamic entities that require energy to sustain and shape them. In an active galaxy, the constant turbulence from newborn stars and dying supernova continuously twists and amplifies the magnetic field, but it also ensures it remains a complex, messy affair. NGC 1277 has had no such activity for 10 billion years. Any magnetic field generated in its youth should have long since decayed, dissipated into a faint and disorganized whisper. The fact that it hasn't, that this organized structure persists with such clarity, suggests one of two incredible possibilities. Either this magnetic field was frozen into the galaxy's primordial gas in the early universe, and has been perfectly preserved in its original state ever since, like a fly in amber. Or there is some unknown, gentle process within this dormant galaxy that is actively maintaining this order, a hidden engine we have not yet begun to comprehend. This discovery forces us to reconsider the very origins of cosmic magnetism. If this field is indeed a preserved relic, it acts as a direct probe into the magnetic conditions of the universe just moments after its first stars began to shine. It suggests that the seeds of galactic magnetic fields were not sown slowly over time through chaotic processes, but were instead imprinted on the cosmos during its formative epochs, perhaps generated by the very first generations of stars or even by processes in the ultra-early universe itself. This organized field could be a fossilized echo of those first magnetic moments, a template from which all other galactic magnetic fields eventually evolved through constant stirring and distortion. In this quiet galaxy, that original template was never overwritten, allowing us to see for the first time what the universe's magnetic blueprint originally looked like. The alternative explanation is equally fascinating. Could this organized field be sustained by the slow, collective motion of the galaxy's ancient stellar population? As billions of stars orbit in the same general direction within the pristine disk, their faint ionized atmospheres, or coronas, could create a vast, slow-moving conductive fluid. This gentle, laminar flow, undisturbed by mergers or new star formation, might be capable of maintaining a large-scale ordered magnetic field through a dynamo effect that is far more serene and coordinated than the violent dynamos we see in younger galaxies. This would mean that a galaxy doesn't need constant violence to sustain a magnetic field. It can achieve a stable, ordered state through a kind of gravitational harmony, a concept that would fundamentally change our understanding of galactic magnetohydrodynamics. Unraveling the mystery of this magnetic field is about more than just understanding one galaxy. It's a key that could unlock the history of how forces shaped the evolution of the entire universe. Magnetic fields play a crucial but poorly understood role in star formation, influencing the collapse of gas clouds and the launching of jets from young stellar objects. They help shape the interstellar medium, the very material from which new stars are born. By studying this pristine, ordered field, we can finally understand the baseline from which all other magnetic fields developed, giving us a pure sample against which to compare the tangled fields of active galaxies. This silent, invisible structure, preserved for eons, is a direct line back to the universe's magnetic infancy, offering clues about the fundamental forces that guided the birth of the first stars and the construction of the first galaxies. A hidden architecture that has been waiting untouched for 10 billion years to tell its story. Now, we turn our attention to the renegades, the cosmic outlaws that have defied the gravitational pull of their own home. Orbiting within the ancient starlight of NGC 1277 are several stars that move with such breathtaking speed that they should not be there at all. Their velocities are not just high, they are extraordinary, far exceeding the escape velocity required to break free from the galaxy's gravitational grasp. According to every conventional model, these stars should have been flung out into the intergalactic void billions of years ago, destined to wander the cold, empty spaces between galaxies as lonely orphans. Yet here they are, still within the galactic volume, tracing paths that scream of a violent and explosive past, their very presence a direct challenge to our understanding of gravitational dynamics within this fossil system. The existence of these unbound stars points to a dramatic ejection event, a cosmic slingshot of unimaginable power. The prime suspect, as with so many mysteries in this galaxy, is the monstrous central black hole. One of the most compelling mechanisms for creating such hypervelocity stars is a gravitational interaction near a supermassive black hole. Imagine a binary star system, two stars orbiting each other, venturing too close to the immense gravitational well at the galaxy's heart. The black hole's tidal forces could violently disrupt the binary, capturing one star into a tight orbit while flinging the other away at a phenomenal speed, like a stone from a sling. This process, known as the Hill's mechanism, could easily impart enough velocity to a star to make it gravitationally unbound. The fact that we see these stars still within the galaxy suggests this event may have occurred relatively recently on a cosmic timescale, or that the galaxy's overall gravitational potential is even deeper and more complex than our current mass models suggest. However, the sheer number of these high-velocity stars raises a fascinating question. Could the central black hole alone be responsible for all of them? The pristine and undisturbed nature of NGC 1277 makes it unlikely that it has experienced the frequent galactic mergers that can also scatter stars to high velocities. This leads to an even more intriguing possibility, that these stars are not the product of a single black hole interaction, but are instead the survivors of a catastrophic encounter with another massive, invisible object. Could an intermediate mass black hole, one of those elusive missing links, have once orbited the galactic core? A close gravitational encounter between this mid-sized black hole and the central supermassive one could have resulted in the smaller object being itself ejected from the core, and in the process, it would have acted like a gravitational bulldozer, scattering any stars in its path and accelerating them to incredible speeds as it was flung outwards. The trajectories of these stars hold the key to unlocking their origin story. By carefully mapping their paths backwards through time, astronomers could theoretically trace them to a point of convergence, a single region of the galaxy where they were all launched simultaneously. If that point is the exact center of the galaxy, it strongly points to the central black hole as the primary engine. But if their paths seem to originate from a different, off-center location, it could be the first indirect evidence of a now absent massive object, a ghostly gravitational signpost pointing to where a second black hole once resided before it too was ejected from the galaxy in a moment of cosmic violence. Each of these high-velocity stars is therefore a tracer bullet, its path etched into space telling the story of a dramatic event that occurred long ago, a silent witness to the hidden forces that have shaped this galaxy from within. Yet another layer of this galaxy's mystery is written in the very color and brightness of its stars, a pattern that defies the standard rules of stellar life cycles. When astronomers plot the stars of NGC 1277 on a color magnitude diagram, a fundamental tool that charts a star's brightness against its color, which indicates its temperature, the resulting distribution is deeply puzzling. It doesn't match the clean, predictable patterns we see in every other galaxy we've studied. In a typical galactic population, stars fall into well-defined regions on this diagram, tracing out clear paths that represent different stages of stellar evolution, from the main sequence where stars spend most of their lives to the giant and white dwarf branches they move to in their old age. But here, the patterns are skewed. There is an unusual overabundance of stars in certain regions and a curious lack of them in others, as if the standard script for how stars are born, live, and die was rewritten for this ancient environment. This isn't just a minor statistical anomaly. It's a fundamental clue that the physical processes governing star formation and evolution were different in the primordial universe that this galaxy preserves. This color magnitude puzzle points directly to the unique initial conditions of the early cosmos. The stars in NGC 1277 formed from gas that was almost pure hydrogen and helium, completely devoid of the heavier elements that act as crucial catalysts in modern stellar interiors. This lack of metals changes everything about a star's internal physics. Without metals to make the gas more opaque, the transfer of energy from a star's core to its surface becomes more efficient, altering its internal structure and ultimately changing its temperature, size, and brightness over its lifetime. Essentially, a metal-poor star of a given mass will follow a different evolutionary path on the color magnitude diagram than its metal-rich counterpart. The strange distribution we see is the collective signature of an entire population of stars that evolved under these exotic and extreme conditions, a fossilized record of stellar physics operating under rules that are no longer common in the universe. One of the most striking features of this peculiar diagram is the apparent absence of certain types of variable stars and the unusual faintness of the red giant branch. In a normal galaxy, we expect to see a well-populated horizontal branch, a region filled with older stars that are undergoing stable helium fusion in their cores. But in this Relic galaxy, that branch seems strangely underpopulated or shifted. This suggests that the evolution from the red giant phase to the horizontal branch may happen differently for these pristine stars. Perhaps they lose mass at a different rate as red giants, or the core helium ignition happens under different conditions, causing them to spend less time in this phase or to appear in a different location on the diagram altogether. This isn't just an academic curiosity. These horizontal branch stars are crucial cosmic yardsticks used to measure distances to old stellar systems. If their properties were different in the early universe, it could have subtle implications for our cosmic distance scale, the very foundation of our three-dimensional map of the cosmos. Furthermore, the main sequence itself, the band where stars fuse hydrogen, might appear narrower or have a different tilt. This could indicate that the stars in NGC 1277 have a different distribution of masses than we see in younger galaxies, perhaps skewed towards higher masses due to the different fragmentation properties of metal-free gas clouds. Or it could mean that the relationship between a star's mass and its luminosity was fundamentally different, a possibility that would require us to revise our most basic models of stellar structure and evolution. The color magnitude diagram of this fossil galaxy is therefore more than just a plot. It is a direct observational test of stellar physics under conditions we can no longer find anywhere else, a window into a time when the stars themselves were built differently, challenging us to understand not just the history of galaxies, but the very nature of the furnaces that light them. But perhaps the most tantalizing mystery of all lies in the very light we capture from this ancient galaxy, hidden within the precise mathematical fingerprints of its atoms. When astronomers direct their spectrographs toward NGC 1277, they break its starlight into a rainbow of colors so detailed it reveals dark and bright lines at specific wavelengths, the unique signature of every chemical element present. These spectral lines are the universe's barcode, and for over a century we have possessed a key to read nearly all of them. Yet, in the light from this fossil galaxy, that key falls short. Scattered throughout its spectrum are faint but distinct lines that refuse to be identified. They are spectral ghosts, emission and absorption features that do not correspond to any known atomic transition of any known element on the periodic table. It's as if we are listening to a cosmic symphony and hearing notes that do not exist on any scale, played by instruments we have never seen. A discovery that hints at the possibility of physics operating beyond our current comprehension. These unidentified lines present a challenge that strikes at the very heart of spectroscopy, one of astronomy's most trusted tools. Every element, when heated or when absorbing light, emits or absorbs photons at precisely defined energies, creating a pattern as unique as a human fingerprint. We have meticulously cataloged the spectral lines for hydrogen, helium, iron, oxygen, and every other element under a vast range of temperatures and densities. The lines from NGC 1277, however, match nothing in our databases. They are not merely shifted versions of known lines due to the galaxy's motion. Their wavelengths are entirely new, suggesting an origin that is fundamentally unfamiliar. This isn't a case of a poorly calibrated instrument or background noise. These are persistent, reproducible features that have been confirmed across multiple observations, making them one of the most compelling and profound anomalies in all of modern astrophysics. Scientists are exploring several extraordinary possibilities to explain these spectral phantoms. The most conservative explanation is that they represent known elements behaving in radically new ways under exotic physical conditions we have not yet been able to replicate on Earth or observe elsewhere. The early universe within NGC 1277 was a place of extreme densities and temperatures. And perhaps under such conditions, the electron energy levels within atoms can be perturbed in ways that create entirely new transition lines. It's possible we are seeing the signature of so-called forbidden transitions. Lines that are theoretically possible, but are so improbable they are almost never observed in laboratories or in younger galaxies with more turbulent environments. The pristine, quiet nature of this relic galaxy might provide the perfect, stable conditions for these faint, rare lines to finally be visible, like hearing a whisper in a silent room that would be drowned out anywhere else. A more thrilling possibility is that these lines are evidence of unknown or exotic forms of matter. For decades, physicists have theorized about the existence of stable, heavy elements that lie beyond the current periodic table, so-called islands of stability, where super-heavy elements might not instantly decay. Could the unique conditions of the early universe, with its incredibly high neutron fluxes during the first supernova explosions, have allowed for the formation of such elements? If so, their spectral signatures would be completely unknown to us, and their presence in this ancient galaxy would represent a fossilized record of nucleosynthesis pathways that are no longer active in the modern cosmos. We would be looking at the chemical ghosts of a more alchemical age, where the rules for building atoms were far more expansive. The most mind-bending hypothesis ventures beyond conventional matter altogether. Some theorists have proposed that certain dark matter candidates, such as actions or other weakly interacting particles, could, under specific conditions, interact with light or with magnetic fields in ways that produce very subtle spectral features. While this remains highly speculative, the presence of unexplained lines in a galaxy that already challenges our understanding of dark matter is a coincidence that demands attention. Could we be seeing not the signature of an unknown atom, but the faint imprint of the universe's most elusive substance finally revealing itself through an interaction we are only just beginning to imagine? Each unidentifiable wavelength is a direct challenge, a small piece of data that refuses to fit into our existing models, pushing us to consider that our periodic table is incomplete or that the fundamental laws governing light and matter have chapters we have not yet read. And now we come to a mystery told not by a single object, but by the very gradient of light across the entire face of this ancient galaxy. When astronomers map the surface brightness of NGC 1277, meticulously measuring how its glow diminishes from its brilliant core to its faint outer edges, they find a profile that refuses to conform. Every major type of galaxy, from elegant spirals to smooth ellipticals, follows a predictable pattern of light distribution, a kind of universal decline that can be modeled by mathematical formulas like the de Vaucouleurs law. These models are the bedrock of galactic astronomy, allowing scientists to infer a galaxy's mass, structure, and history simply by charting its light. But this relic galaxy is a nonconformist. Its surface brightness profile is subtly distorted, falling off in a way that is just wrong. The light doesn't fade as steeply as it should in the outer regions, indicating that the galaxy holds onto its stars with a gravitational tenacity that our standard models simply cannot account for based on the visible mass alone. It's as if the galaxy's luminous body is stretched and extended beyond its expected boundaries, a cosmic silhouette that is both familiar and eerily alien. This anomaly is a powerful clue written in photons, and it points directly to the galaxy's most profound secret, its mass distribution. The way light is spread across a galaxy is a direct tracer of its underlying gravitational field, which is dictated by both the visible stars and the invisible dark matter. The strange, extended glow of NGC 1277 suggests that its mass is not arranged in the way we've come to expect. In a typical galaxy, the density of both stars and dark matter drops off predictably with distance from the center. But here, the gravitational anchor seems to hold firm much farther out, creating a gravitational well that is both deeper and wider than the visible starlight would imply. This creates a fascinating contradiction. The motions of stars within the galaxy suggest a lack of dark matter, yet the overall light profile suggests an additional, unseen mass that is stretching the galaxy's luminous form. It's another piece of the puzzle that simply doesn't fit, forcing us to question whether the dark matter is truly missing or if it's just hiding in a configuration we've never seen before. One compelling explanation is that we are witnessing the signature of a uniquely pristine formation history. Most galaxies are built over time through a series of mergers, a chaotic process that violently puffs up their outer regions and scatters stars into a more diffuse halo. But NGC 1277, having never experienced a major merger, may have retained its original, tightly bound structure. Its stars may have formed in a single, incredibly rapid and efficient collapse from a vast cloud of primordial gas. This monolithic collapse could have resulted in a stellar distribution that is inherently more compact and extended in a specific way. A fossilized imprint of a formation process that was far more orderly and direct than the messy hierarchical buildup we see in other galaxies. Its light profile isn't wrong. It's just pure. A perfect preservation of a galactic blueprint that was common in the early universe, but has been almost entirely erased everywhere else. The implications of this strange light distribution ripple outward, touching upon one of the most practical tools in an astronomer's kit: distance measurement. The consistent nature of surface brightness profiles is often used as a standard ruler to gauge how far away distant galaxies are. By assuming a typical size and brightness, astronomers can calculate distances across the universe. But if NGC 1277 represents a class of galaxies that fundamentally deviates from this standard, it means that any galaxy we find with a similar pristine, relic nature could throw off our cosmic distance calculations if we mistakenly apply the standard models to it. This anomaly serves as a crucial warning that our assumptions about uniformity in the universe might need to be refined, especially when looking back to the earliest epochs where such pure, unmerged galaxies were more common. Its unusual glow is therefore more than just a curiosity. It is a calibration tool, teaching us to read the light of the cosmos with a more nuanced and critical eye. But perhaps the most captivating mysteries within this ancient galaxy are those that unfold over time itself, a series of enigmatic objects whose very light refuses to shine with any predictable rhythm. We are now looking at the 28th strange object, or rather, a collection of phenomena known as mysterious time domain events. These are not the steady, clockwork pulses of a spinning neutron star or the predictable dimming of an eclipsing binary system. Instead, these objects flicker, flare, and fade in a chaotic and seemingly random ballet of light, their patterns completely unlike any catalogued variable star or known astrophysical engine. It's as if someone is randomly fiddling with a cosmic dimmer switch, creating a stuttering light show that defies all classification and points toward entirely new physical processes lurking within this fossilized realm. Imagine training a telescope on a single point of light for years, patiently recording its brightness every night, expecting the gentle, predictable variations of an aging star. Instead, you witness a light curve that looks more like a seismograph during an earthquake, a series of violent, sporadic spikes and plunges with no discernible pattern, periodicity, or cause. One of these objects might remain perfectly steady for decades, then without warning, suddenly double in brightness over a single night before just as rapidly fading back into obscurity. Another might exhibit a rapid series of micro-flares, popping like cosmic popcorn for a few weeks before falling silent for a century. This erratic behavior is the hallmark of something truly novel. In a universe governed by physical laws, we expect causes to have effects, and energetic outputs to have logical power sources. These time domain anomalies seem to play by a different set of rules, their bizarre variability suggesting engines or mechanisms we have not yet begun to imagine. One compelling hypothesis for these flickering enigmas involves the possibility of rare and exotic stellar interactions, events made more probable by the galaxy's densely packed core. Consider a neutron star with an incredibly powerful magnetic field, a magnetar, on a long-period orbit around a cold, ancient star. As the magnetar swings through the periastron of its elliptical orbit, its immense magnetic field could violently interact with the atmosphere of its companion, channeling stellar material and triggering colossal flares that shine brilliantly across multiple wavelengths before ceasing as the star moves away again. The irregular timing of these orbital encounters, combined with the unstable nature of the accretion process, could produce the utterly unpredictable light curve we observe. This would be a binary system unlike any other, a dormant pair that periodically erupts in a spectacular but brief fury. Another fascinating possibility is that we are witnessing the final, sputtering breaths of a stellar remnant that should be cold and dark. A white dwarf, the Earth-sized core of a dead star, might drift through a region of space still thick with the ancient debris from the galaxy's formative years. If this dense cinder were to occasionally plow through a particularly dense knot of this primordial gas and dust, the sudden accretion of material could trigger a short-lived reignition of nuclear fusion on its surface. This would cause the dead star to flare back to life with a brilliant and completely unpredictable burst of light, a phoenix flaring in the darkness, before fading away again once it has consumed its unexpected meal. The pristine, untouched nature of NGC 1277 means such fossil debris fields could still be intact, making this kind of rare event more likely to be witnessed here than in any other galaxy. The most thrilling explanation, however, ventures into the realm of the truly unknown. Could this erratic variability be the signature of a theoretical object finally revealing itself? For decades, astrophysicists have speculated about the existence of intermediate-mass black holes, the missing link between stellar mass and supermassive giants. One of these elusive objects, wandering through the galaxy, would be a gravitational predator largely invisible to us, but its passage would not be completely silent. As it drifts through the interstellar medium, it would occasionally snatch and tear apart small, passing objects, an asteroid, a comet, or even a small planetesimal that survived from the galaxy's earliest days. Each time it consumes one of these cosmic morsels, the tidal disruption event would create a short-lived, flaring accretion disk that shines brightly across the optical and ultraviolet spectrum before quickly vanishing. The random timing of these snack attacks would produce a light curve of unmatched chaos, a signature of a hidden monster slowly grazing its way through the ancient stellar population. Each mysterious flicker of light is therefore a potential signal, a breadcrumb trail leading us toward a deeper understanding of the hidden inhabitants of this cosmic relic and the strange, time-dependent physics that govern them. Within the silent expanse of this ancient galaxy, we encounter a profound and telling void, a missing ingredient that is as crucial to a galaxy's life as oxygen is to a fire. This is the baffling absence of molecular clouds, the vast, cold, and dense nurseries where new stars are born. In every other active galaxy, these cosmic wombs are abundant, glowing with the faint radio signatures of molecules like carbon monoxide and hydrogen, tracing the potential for future stellar generations. They are the galactic fuel reserves, the raw material for creation. But in NGC 1277, this reservoir is almost entirely empty. The radio telescopes listening for the whispers of these cold clouds hear only a deafening silence, confirming that the galaxy's star-forming engines didn't just idle down. They were permanently starved of fuel and shut off over 10 billion years ago. This complete lack of molecular gas is the definitive, final piece of evidence that confirms its status as a true relic. But it simultaneously deepens the central mystery of how such a thorough and permanent shutdown was even possible. The puzzle isn't just that the gas is gone, it's the mechanism of its removal. How does a galaxy as massive as this one lose every last trace of its star-forming potential? Galactic evolution isn't typically so absolute. Most galaxies experience a gradual quenching, a slow fading as their gas is consumed, blown away, or stripped over long periods. But the evidence here points to something far more dramatic and decisive. One leading theory places the blame squarely on the galaxy's own monstrous heart. During its frenzied initial burst of star formation, the supermassive black hole would have been an insatiable beast, gorging on vast quantities of matter. This feeding frenzy would have unleashed a catastrophic feedback event, a torrent of energy in the form of powerful jets and intense radiation that blasted through the galaxy. This energy would have heated the remaining vast clouds of cold molecular hydrogen, preventing them from collapsing into new stars and effectively boiling them away into a thin, hot, and diffuse plasma that could no longer form stars or simply ejecting it from the galaxy entirely. It's a cosmic version of a hurricane scouring a landscape of all its moisture, leaving behind a permanent drought. Another compelling explanation looks to the galaxy's harsh environment. NGC 1277 is not a hermit. It orbits within the crowded and violent Perseus galaxy cluster, which is filled with a superheated plasma known as the intracluster medium. As the galaxy hurtles through this scorching gas at immense speeds, it rams into the thin but pervasive medium, experiencing a phenomenal pressure. This ram pressure stripping could have acted like a cosmic blowtorch, violently ripping the cold molecular gas directly from the galaxy's gravitational grip. The process is akin to the powerful wind you feel sticking your hand out of a car window, but on an unimaginable scale, powerful enough to rob a galaxy of its future. The galaxy's high velocity through the cluster would have made it particularly vulnerable to this form of interstellar theft, potentially explaining the thorough and complete nature of the gas loss. There is, however, a third and even more intriguing possibility: that the galaxy simply used it all up in one glorious, unsustainable firestorm of creation. Its initial burst of star formation may have been so incredibly voracious and efficient that it consumed nearly 100% of the available primordial molecular gas in one go. Imagine a massive, pristine reservoir of cold gas collapsing under its own gravity, igniting a ferocious firestorm of star birth that lit up the early universe. But this was a single feast that left no leftovers for a later meal. In this scenario, the galaxy didn't lose its gas. It converted it entirely into that first, metal-poor generation of stars. The absence of molecular clouds isn't a mystery of loss, but a signature of astonishing and complete efficiency, a testament to a formative era when the rules of galactic construction allowed for such extreme and definitive outcomes. This would make NGC 1277 a cosmic example of live fast, die young, a galaxy that burned with incredible brilliance for a short time and then faded into a permanent, quiet retirement, its potential exhausted in a single, epic burst of cosmic ambition. And now we arrive at the 30th and perhaps most profound mystery, one that isn't seen with light at all, but felt through the very ripples in the fabric of space-time. Hidden within the ancient dance of this galaxy are several bizarre binary systems, pairs of massive objects locked in such tight, fast, and decaying orbits that they should be among the universe's brightest sources of gravitational waves. Yet when we analyze their characteristics, they refuse to fit into any known category. These are not the well-understood mergers of stellar mass black holes or the frantic spirals of neutron star pairs that our observatories like LIGO and Virgo routinely detect. These are gravitational wave candidates with parameters that are deeply strange, suggesting the existence of binary systems built from components we have not yet catalogued, orbiting in ways that defy our models of cosmic evolution. Imagine two objects, each with a mass tens of thousands of times greater than our Sun, locked in an orbital embrace so tight that they complete a full revolution around each other not in millennia, but in a matter of mere hours. The energy they lose to gravitational waves with each orbit is stupendous, causing their paths to spiral inward at a rate we can almost measure in real time. According to our understanding, such a system should be a pair of intermediate mass black holes, the long-sought missing link between stellar and supermassive varieties. But the inferred masses and orbital separations of these candidates in NGC 1277 don't quite match the predictions for how such pairs should form or behave. Their orbits are either too eccentric, their in-spiral rates too rapid, or their combined masses too low for the incredible amount of gravitational energy they seem to be radiating. It's as if we've discovered an engine that runs on a fuel we cannot identify, operating with an efficiency that breaks the known laws of thermodynamics. One particularly compelling candidate appears to be a binary system where one member is the galaxy's central supermassive black hole itself. The other object, however, is not a predictable partner. Its gravitational influence suggests a mass that is far too large to be a stellar mass black hole, yet not quite large enough to comfortably fit the profile of a standard intermediate mass black hole. It's as if we've found a gravitational ghost, an object of almost impossible density that is locked in a death spiral with the central behemoth. The gravitational waves emitted by such an exotic pair would have a unique fingerprint, a low-frequency hum that would be entirely new to our catalogs, a sound that whispers of formation pathways we have not yet considered. Another system suggests an even more bizarre configuration, a binary where the two objects have wildly mismatched masses. Picture a supermassive black hole paired with an incredibly dense, dark cluster of something else, perhaps a tight knot of stellar mass black holes or a previously hypothetical object like a boson star. The gravitational wave signal from such an asymmetric pairing would be unlike the clean chirp of two equal masses merging. It would be a complex, warped signal, with harmonics and modulations that could only be produced by a pair of objects that shouldn't logically exist together in a stable orbit for billions of years. The fact that they have, and that we can detect the subtle orbital decay, suggests that our understanding of stability in extreme gravitational fields is incomplete. The existence of these anomalous candidates forces a radical rethink of how binary systems evolve in an environment frozen in time. In a normal galaxy, dynamical friction, the gravitational drag from countless stars and gas clouds, would naturally cause massive objects to sink toward the center and pair up. But NGC 1277 has been devoid of such material for eons. So how did these bizarre binaries form and persist? One theory is that they are primordial, forming together in the same incredibly dense gas cloud during the galaxy's initial collapse, a pair of gravitational seeds born in the same cosmic instant and destined to orbit each other forever. Their unusual parameters would then be a fossilized record of a binary formation process that was common in the early universe, but has been erased everywhere else by later mergers and interactions. Unlocking the secrets of these gravitational wave candidates is about more than just adding new entries to a catalog. It's about opening a new window into the universe. Each unusual orbit is a natural laboratory for testing general relativity under conditions of extreme gravity that we could never replicate on Earth. The precise timing of their orbital decay provides a direct, exquisite measure of the properties of spacetime itself. Furthermore, if these signals can ever be directly detected by future space-based observatories like LISA, they will provide a completely independent method to weigh the black holes and measure the distance to this fossil galaxy, offering a new cosmic ruler to probe the expansion history of the universe. These silent, invisible binaries are therefore not just the final strange object in our list. They are a promise of a new era of discovery, where the subtle ripples they create in spacetime will allow us to listen to the universe's deepest secrets, hearing the echoes of a past that light alone can never reveal. So here we are at the end of our journey, having ventured through 30 profound mysteries locked within a single ancient galaxy. From a supermassive black hole of impossible proportions to the complete absence of the dark matter that should anchor it, from unexplained gamma-ray hums to stars moving with unbound velocity, each object is a cosmic paradox. We've encountered strange chemical fingerprints, a perfectly preserved magnetic field, erratic time domain events, and gravitational wave candidates that defy classification. Together, these 30 anomalies don't just challenge a single theory. They collectively question the very foundations of our understanding of how galaxies form, evolve, and function. NGC 1277 isn't merely an oddity. It is a comprehensive and systematic rejection of our standard models, a celestial rebel that proves the early universe operated under a different, more extreme set of rules that we are only just beginning to glimpse. This pristine fossil galaxy has become one of the most valuable laboratories in all of astronomy, precisely because it pressed pause over 10 billion years ago. While every other galaxy continued to be stirred, shredded, and recycled by collisions and new star birth, this one remained sealed, preserving a perfect snapshot of the universe's infancy. By studying its untouched stars, its unique binaries, and its bizarre emissions, we aren't just learning about one peculiar island universe. We are calibrating our entire cosmic history. It provides the pure, unadulterated baseline data we desperately need to understand the messy, complex evolution of galaxies like our own Milky Way. Each mystery solved here will send ripples through cosmology, potentially refining our measurements of dark matter, rewriting the rules of gravity, and revealing new pathways for black hole formation that we never knew existed. The greatest lesson from NGC 1277 is a humbling one. The universe is far more inventive and mysterious than we ever imagined. For every rule we think we've discovered, there is an exception waiting in the shadows, a cosmic relic that dares to be different. This galaxy forces us to ask what other secrets are still hidden within the faint light of other ancient galaxies. What if NGC 1277 isn't the only one? What if it's simply the first of a forgotten population of relic galaxies, each holding its own set of 30 mysteries that could further reshape our story? The pursuit of these answers is what drives astronomy forward, reminding us that the cosmos is a place of endless wonder, always ready to surprise us with something new. Now, we'd love to hear what you think. Which of these 30 mysteries captivates you the most? Is it the missing dark matter, the unexplained gamma rays, or the idea of a perfectly preserved magnetic field from the dawn of time? Share your thoughts in the comments below, and let's keep the conversation about this incredible cosmic fossil going.